Right, references and borrowing. So the issue with the tuple code in listing 4.5 is that we have to return the string to the calling function, so we can still use the string after the call to calculate length, because the string was moved into calculate length. It is how you would define and use a calculate length function that has a reference to an object as a parameter, instead of taking ownership of the value. Right, so this creates a string now as an object, and instead of passing the object, I think the last example they were passing an object to the function and then returning the same, returning the same object, I believe. So in this case, they're passing a reference, and it just reads the length. So it means they can still use the S1 object after the function has been called. First, notice that all the tuple code in the variable declaration and the function return value is gone. Second, note that we pass S1 into calculate length, and in its definition, we take a reference to a string rather than string. These ampersands and references, these ampersands are references, and they allow you to refer to some value without taking ownership of it. So figure 4.5 shows a diagram. So you have a pointer here to the string, and it's just saying this is the value in memory, I suppose. Let me just hold on. Okay. So S1 is the object, the pointer to the memory that lives on the heap. And when you create S here, which is a reference, it's really just a pointer to the pointer to the memory on the heap. Note, the opposite of referencing by using the ampersand is the referencing, which is accomplished with the reference operator, star. We'll see some uses of the reference operator in chapter 8 and discuss details of the referencing in chapter 15. So any questions so far? Or anyone, is this clear to everybody? Okay, we'll move on. Let's take a closer look at the function call here. The ampersand S1 syntax lets us create a reference that refers to the value of S1, but does not own it. Because it does not own it, the value it points to will not be dropped when the reference goes out of scope. Likewise, the signature of the function uses an ampersand to indicate that the type of the parameter S is a reference. Let's add some explanatory annotations. Yeah, so it's basically saying that S is a reference, is an immutable reference, so you cannot change it. And at the end of the function, when it gets out of scope, the memory that it points to is not dropped. So it's just temporarily borrowed here, and this is a read operation, so it can read the memory for a little bit, and then it goes out of scope. But the original string is still in memory. It hasn't been freed. So
I'm assuming you can still have a mutable reference as well, right?
A mutable one?
Yeah.
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 So you could pass a mutable reference in here. Do you want to run some example with that?
You can if you want.
Yeah, you can try.
I think we did it last time, to be honest, but
I think the thing to point out here as well is that even though it's a reference, if you want to call a function, you still use the double as a move.
Yeah.
It's not like in C++, for example, you have like an arrow thing. If
Yeah.
you have a pointer, you have to use the arrow. If you have the actual value, you do dot. Whereas if you want to access,
Oh,
as if you wanted to access the actual string object,
Yeah.
you would use the star dereference it, but you don't have to dereference it if you're calling the function.
Yeah, that's a good point. So if we had that, for example, well, yeah, let's just do. So if I pass in the reference here, I make this mutable.
yeah.
So this is a mutable variable. And then I'm not sure if I have to put this here. I think I have to put that. So I'm gonna modify the variable in there, and then I will print it.
Bigger, can you make it a little bit bigger?
Sorry.
Yes.
Okay.
Yeah.
Okay. And then in here, let's just see what we have. And method, I think. Just put something a little more. Don't return anything. Does that look okay? Do you think that's gonna work? I think that's gonna work. Let's see.
It's kind of scary how much is like the following example in the book.
Ah, really? Hang on a minute. Cannot find function. Oh, sorry.
Oh, so it's a pen word.
Yeah, I just changed it. Expected. Okay, so it expects a slice. So usually when you have a string, you can just put this here. Well, actually, I can just pass.
A string slice.
I just can just pass string slice here. That. See there. Yeah. So that's how you pass a mutable one there. It's fine. The scope in which the variable s is valid is the same as any function parameter scope, but we don't drop what the reference points to when it goes out of scope because we don't have ownership. When functions have references as parameters instead of actual values, we won't need to return the values in order to give back ownership because we never had ownership. We call having references as function parameters borrowing, as in real life. If a person owns something, you can borrow it from them. When you're done, you have to give it back. So what happens if we try to modify something we're borrowing? Try the code in listing 4.6. Spoiler alert, it doesn't work. Oh yeah, so it's...
It's a good. Yeah, you did this before.
oh, exactly the same one. Yeah, but so at the wow. Well, Hello World is a classic anyway.
Why are they saying it won't come?
Because it's passing an immutable reference.
Actually, for example.
So obviously, if you're passing an immutable reference, then well, first of all, if I pass an immutable reference here and it doesn't match the function signature, it also won't work.
Yeah.
I think I'm not exactly sure. In this case. Yeah, so you can't. So I'm saying I need a mutable reference because I'm going to append something. Therefore, whoever calls this function must explicitly say that it's going to be mutated. Yeah, but obviously, if this was immutable, then you can call push string. You cannot, and it's because if we look at that function, push string on strings, the first parameter is a mutable reference to self. So, which will work if we have ownership, but because we don't have ownership, then we cannot do this. Okay. Just as variables are immutable by default, so are references. We're not allowed to modify something we have a reference to. So mutable references, we can fix the error in the code from listing 4.6 with just a small tweak. So here I'm putting the mutable references as we saw. So there's nothing new there. First, we had to change S to be mutable. Then we had to create a mutable reference with mutable S. So here they create a mutable reference and accept a mutable reference with some string, mutable string here.
That changed by the keyword then.
Say again?
So the bit that says change to mutable S first with the function. Change, no, if you go.
No, it's just a function that's defined right underneath.
Yeah.
So it's different change
So it's defined change, right?
after that.
Here,
Ah.
this is changed.
Okay.
Any questions so far? All good? Easy, isn't it?
Looks like that.
So first we had to change, sorry, I read that. But mutable references have one big restriction. You can only have one mutable reference to a particular piece of data in a particular scope. So this code will fail. Okay, so this gets interesting now. So we have a mutable variable to a string hello. And then we create a mutable reference to that string. And then we try to create another one in the same scope. So it means there are two mutable references in the same scope. So there is the error, cannot borrow S as mutable more than once at a time. This restriction allows for mutation, but in a very controlled fashion. It's something that new Rustaceans struggle with, because most languages let you mutate whenever you like. The benefit of having this restriction is that Rust can prevent data races at compile time. A data race is similar to a race condition and happens when these three behaviors occur. So two or more pointers can access the same data at the same time. At least one of the pointers is being used to write the data. There is no mechanism being used to synchronize access to data. So I think the way you handle this in other languages is by enforcing, kind of controlling who is writing and who is reading to the variable at runtime, which has a cost. Whereas in Rust, you can be confident that you're not going to have data races, and it doesn't cost you anything because there is no code checking at runtime. There's only one piece of code trying to write or read from the data. So data races can cause undefined behavior and can be difficult to diagnose and fix when you're trying to track them down at runtime. Rust prevents this problem from happening because it won't even compile code with data races. As always, we can use curly brackets to create a new scope, allowing for multiple mutable references, just not simultaneous ones. Yeah, so it creates a string. And then you can have a mutable reference inside one scope or inside a function. And you can only create another one once the first one has gone out of scope. So that's fine. A similar rule exists for combining mutable and immutable references. This code results in an error. So trying to creates a string, it assigns an immutable reference, no problem. Second immutable reference, no problem either. And then when tries to create a mutable reference, it's a big problem. This is the error. Cannot borrow S as mutable because it's also borrowed as immutable. Right, so you cannot have mutable reference and immutable reference at the same time. We also cannot have a mutable reference while we have an immutable one. Users of an immutable reference don't expect the values to suddenly change out from under them. However, multiple immutable references are okay because no one who is just reading the data has the ability to affect anyone else's reading the data. Even though these errors might be frustrating at times, remember that it's the Rust compiler pointing out a potential bug early at compile time rather than at runtime, and showing you exactly where the problem is. Then you don't have to track down why your data isn't what you thought it was. Yeah, so this is just amazing that they do that. I mean, especially like being a PHP developer, like I come across issues like this all the time. So for me, this is so good. Even if it's a little bit difficult in the beginning. Any questions so far? Nothing? Do you guys want to run, if you guys want to run some code examples or anything, let me know if there's any doubts at all. I don't know. Saying usually is always in the editor, so, but I'm just reading through, so. Okay, so move on. Yeah, okay. Dangling references. So in languages with pointers, it's easy to erroneously create a dangling pointer.
So,
Yeah.
let me go back a sec. Can you, like, can you shadow a variable that was, so a variable that was once a immutable reference, and then shadow it with the immutable reference of the same thing?
You mean make a reference to a mutable object?
Yeah, so you have like, I mean, I don't see, I'm not entirely sure of the reason why it wouldn't work. It also feels like it's a little bit of a hack. Like you have a variable that takes a reference of something. So
let's say this string, yeah?
Yeah.
So you want to, so I call it something else, this one?
Let's call that B. Yeah, B has a immutable reference of A.
Yeah.
And then
you will
let B equal
shadow
to
B with a
mutable reference of A.
Okay.
Compile?
Well, it should, right?
It might think that you're trying to make the references of the same thing, but at the same time you're not. So does it notice that?
I'm not sure.
I think this was like its own scope, right? Kind of thing.
Yeah, that's what I'm saying.
Let's see. But yeah, that's a good point. No. Cannot borrow A as mutable because it is also borrowed as immutable.
Yeah, but I was overwriting it. So
Yeah, no, you can't.
This might be one of those things that will start to compile and some improvements to the borrow checking code at some point.
Yeah.
So working on making it more clever about not rejecting code would be okay.
right.
What happens if you reverse it, make the mutable first? Does that make a difference? Or?
Should be.
No,
The rules break.
I think the rule is you can have both.
No, it's worth trying.
I guess yeah.
It's whatever.
Yeah.
Yeah. So it just doesn't let you do opposite types,
Yeah.
and it doesn't let you do multiple of the mutable.
Yeah, exactly.
Not in the same scope.
Yeah, you can have as many reads as you want.
You can have as many read as you want, but so you can read at the same time as you write. That's the thing, right? So, or write at the same time. Yeah. I guess the compiler. I think the compiler doesn't really know what's happening in between, or it doesn't really care. Like if we were to clone B or something like that in here, or pass it to a thread or something. I guess it's hard for the compiler to know that.
Yes, it's also.
I think-
Yeah, go ahead.
Sorry, I think it is what Alistair's saying is that it's not been smart enough about the assignment of another reference to B.
Yeah.
When non-lexical lifetimes come in, it may fix it.
Okay.
The thing I was wondering about was, I was wondering if it would be able to enforce this in multi-threading. How does it know that thread will be like? If you have like a thread that's a reader and a thread that's a writer, you want the reader to have immutable reference, and you want your writer to have an immutable one. But if each one of those, the part that does the reading and writing is like a function, then how does the compiler know that those two functions will actually be at the same time? Like it can't.
Yeah, it doesn't know that. You have to use a mutex. You have to use a smart pointer that enforces that at runtime. That gets a lock, right? There's no way to say I'm passing a thread just a plain reference.
Well, you can pass ownership. Right?
If you pass ownership, but you can only pass ownership to one thread.
Yeah.
But he's saying if you have two threads with access to the same.
I think that you can pass read references.
Yeah, but
Both of them, but then the writer wants to write,
But
so
you
it
can't
needs.
have a read and a write. That's like
Yeah,
that's the whole rule. Like you can't do it. I guess.
but I guess how does the
That's
I'm wondering if the compiler will be able to enforce it because it doesn't know that they're at the same spot. Like at this point in the code, it just says someone took a mutable reference, and at this point in the code, in like some other file, it says, oh, someone took a mutable reference. But like, how does it know that they're both supposed to be running synchronously and aren't just two bits of code, two separate files that will run at some point? Yeah, I guess.
I think somehow it knows when you pass it into a thread. I think there's a distinction if you're passing into a thread. It knows. It knows that you're passing it into a thread, and therefore it only allows you to have. I mean, it enforces more.
So going back to that first example we were looking at with you shadowed reference and something like it, if you enable non-lexical lifetimes on Nightly, it does accept it.
Okay.
It's just limitations in the current borrow checker.
Right.
Is that
That's good to know.
a thing on Playwright?
Yes, you can just drop down the thing that says stable and change to Nightly.
Interesting.
And then there's a feature switch as well. So on line 1, you need to go hash exclamation mark, in square brackets, feature, open round brackets, round brackets, NLL. NLL.
Run lexical lifetimes.
Oh, yeah.
With no actual error.
Okay.
Cool.
It's getting better.
Super cool.
Cool. Yeah, so in languages with pointers, it's easy to erroneously create a dangling pointer, a pointer that references a location in memory that might have been given to someone else by freeing some memory while preserving a pointer to that memory. In Rust, by contrast, the compiler guarantees that references will never be dangling references. If you have a reference to some data, the compiler will ensure that the data will not go out of scope before the reference to the data does. Let's try to create a dangling reference, which Rust will prevent with a compile time error. Right, let's copy this code. Okay, so it has a function dangle which returns a reference to. It creates a variable in here and then it returns a reference to that. But then, because the scope finishes here, that reference is gonna go out of scope, and this will get nothing. This will get how do they call it? Dangling pointer.
The thing I tried to explain weeks ago, and I forgot what I was saying halfway. Anyway, that's it.
So missing lifetime specifier. This function's return type contains a borrowed value, but there is no value for it to be borrowed from. Consider giving it a static lifetime. So this is I don't know how this works. I don't know much about lifetime, but how we actually do this.
I think so. I think it's just lying to you.
It's just lying to us.
I don't know if this works.
Really? Does not live long enough. Damn.
There's no way.
You can't get to it.
There's no way of like
You can't get to it.
returning a value out of this function.
How about this?
So then,
It's nothing, right?
like, yeah, I don't know.
Instead of doing let, you do static s.
Oh, no. Is it?
Maybe.
Constant.
That is a keyword, so.
Presumably, if you're calling string from, you inherently get something that's not static anymore. You might have to use string literal.
Like that? Right,
So I
so
mean, instead of on line 6, instead of saying string from hello, it's the string literal hello, because that is then an ampersand from static str.
okay.
That's
Let's see.
the element.
Yeah. Let's stop.
No, things on about returning a string slice, but are static. So
This
get
one
rid of
here?
the static, because I don't think
Here?
it's valid code.
Or here?
On line 6, get rid of that static, so I don't think that's valid.
Yeah, this is the thing that's right here. So let.
Yeah, and then get rid of string from and just make it a string slice with and static. So instead of function.
Oh, yeah.
And then change
I was thinking you
the
probably don't need the ampersand parentheses.
Hold on a minute.
change the function, so you're going to change the and
Is it like this?
then and true.
Do I need this one here? Maybe.
Yeah.
In theory, right, we think it's creating a static reference to a string, and then we're passing that back. Should work. str. Expected.
colon.
Oh yeah, so it's like this.
Oh, to the left hand side of the
So what I was
assignment.
thinking is just let s equals hello, ampersand s.
Well, actually, according to the docs,
Oh,
they
you-
do static and then the variable name colon, and then I assume I32 is a type.
Are you saying in
So
this?
they do static s colon, the type,
The type
Which
is
is
this,
the
yeah.
way you define something normally.
and then
I like that.
and then equals. Yeah.
Yeah, because you'd put the mute on the.
So missing. Okay, so now it's complaining about missing lifetime.
Oh, yeah, you need ampersand apostrophe static, yeah.
Oh wow.
And after the colon as well. Oh, no, that works.
No, that works, man. Wow.
Oh, okay.
Didn't know you would static there.
Let's not do that.
That looks horrific.
Is that also you can return a reference to something that you want to continue living after you create it inside function?
Well, apparently what we've just done is created a global variable of sorts.
Yeah, that's fine.
So
Yeah,
Yeah, so
it's just forever.
Not the best thing to do, I suppose.
You reference to
Well, yeah.
But you're still trying to grow global. Is
I'm
what
curious
it
why
sounds
you didn't say static on the
like. With this static keyword.
And here?
Yeah.
Basically, I've never seen it
Why does
static
it care
keyword
about that?
used.
Why-
Okay.
So,
Yeah, I think.
it's simply to think about it this way that it's not actually, you know.
No, exactly.
Because you don't-
I guess you have to be
if
explicit
you
about
for instance,
if this is gonna live
it's
forever.
that
But,
you
But I mean, you never need to put
We're
on that
demonstrating that
table
scope. It
or
has
anything else.
lifetime, so live.
I guess.
Oh, but because-
You end up
So,
being
Static
like
exists for the lifetime of the
Based on
sorry,
the
for the runtime
Right,
of the
that's
program.
returning a reference.
So it's technical.
But it's not down to your point.
Something
No,
else
it
refer to that.
It is, it's right into the runtime.
Not
So could something else refer to that?
Right.
Out of interest, does it work if you remove the static from the return type and put it on the
Or if you don't
actual
return,
definition instead? Sorry, the declaration.
Here, you want to know if it like infers it or something.
I'm not gonna go down
Yeah.
that hole.
It's like a deep rabbit hole.
I think
So,
static can
let's
technically
do
live
this,
for
yeah,
that, it's up to them.
We're not into that hole.
But that's
Um,
more.
Then you have to do static reference to
I think
the
this is possibly the simplest version that works.
Oh, wow.
No, I think you still have to put it in here, right? You have to put the lifetime. No, you have to put in here apparently.
Oh,
Does
okay.
it put it
Always.
into a global table when it's static?
The let the variable function. The function. With the static key. It changes.
So when's that get stored?
Learn something new today.
To be referenced?
Well, I guess it's stored somewhere inside the program itself, isn't it? Because it's a string literal.
I mean, what's interesting
So
about
it'll be
that
pointed
is
somewhere into the binary.
So you don't need static for that then, really. Like you can't you just return?
It's an interesting question if I
well, what's
Yeah,
interesting
that's
about that
it.
is
Yeah,
that
it's
returning a
line.
new static variable.
No, no, understand.
it's quite a
Because
large
those-
parameter. So
Because those
I think
levels
this
are
is a good
supposed to
idea.
be in like a.
Might be in every single function. Because it is verbal.
They were in like.
It's a thing, maybe it's a good job,
it's not.
which is different by the
I
shit.
think for literals it's not too bad.
Yeah, but I mean, it
Yeah, yes.
wouldn't necessarily need the word static there. It's always going to be there. The lifetime is already set by the fact that it's literal.
Yes,
The pilot doesn't like it. I think.
but obviously you can't just go around pointing out static on everything. It only works because it's a literal.
Yeah, unless you created the variable static. Like unless you somehow did string from, but made it so that string from would make a static variable.
I don't think that's possible.
Is that where the static?
I think
If
that's
you
maybe where this
Oh,
keyword comes
is that-
from.
will that work?
So if you just do string from on the hello,
If you, oh, sorry.
and just keep the static. Keep the static on the like. Does that mean you define the lifetime for it?
Okay, so here, right? If I do this, so this is a string, static string, right? So I mean,
Yeah. So does that mean the string? is
You need to
static?
change the return type.
Yeah, that's true.
and that should be just a string.
Yeah, but then you fit.
You need,
No, I think it was
you
still.
need to bring the
static.
lifetime,
Of what?
which you don't need the lifetime.
Let's see. I don't know. Let's see.
I guess you just return it. No.
Obviously, cannot move out of the static gate.
Yeah, because you're moving it out, so you need to return a reference to it.
Okay. Right. Yeah, that makes sense. So, like that, yeah.
And then behind stuff, yeah.
Rabbit hole.
Calls in statics are limited to constant functions.
I see.
Tuple
Yeah.
structs.
That's a good point.
So is static just a shorthand for let S colon static?
Also, putting this here is the same as doing this.
Colon, yeah, and static.
Kind of thing, right? Or whatever type you have.
Yeah, is it just shorthand for that?
So it's saying you cannot have this. These are not compatible, maybe these two, a string and having a static. Why is it saying here calls in static are limited to constant functions?
Because you're dynamically creating a string from.
Yeah.
Yeah.
Yeah, I think it's the equivalent. I've seen this error before by like constants as well.
I'm assuming what it's saying is that that function is dynamic and not static. Like for example, in C++, if you tried to call into a static function, so no, if you tried to call a non-static function from a static context, it would let you.
Okay. And this is the bit that's dynamic, right?
Yeah,
This could be.
that's a non-static function.
Yeah.
Straightforward.
Oh yeah, I remember reading about this.
So
So yeah,
these-
basically, they are a constant kind of.
So this is now by definition a static function, I suppose. Because you
Yes, because you've included the word static in one of the variables.
All right.
That makes that a static function.
Okay. Yeah, because in PHP you do like static here.
Yeah,
You say this is static.
Chapter 19 of the book suggests that static variables are always global, so they're, in an example, they just always declare them outside of any function.
Say again, sorry?
According to chapter 19, static variables are global, so you just declare them outside of any function.
so could we declare outside of main then?
Yes.
Just on its own.
So their example, which is static hello world ampersand str equals correct hello world, and then function main rebind my world.
Yes, that's how
That
you would do
makes sense,
static in anywhere
actually.
else. Yeah,
Yeah.
that's how you would do static in a lot of other languages where it would just be static.
But then can that not just be a const? Oh, I suppose if you're.
Yeah, so it actually says they're similar to constants, but static items aren't inlined upon use.
Oh,
This means that there is only one instance for each value, and it's a fixed location in memory.
Whereas constants are not like that.
I think the difference would be that if you change that to a const on line 9, then it would be dropped and it would have its own scope, I think.
It's a constant in the scope.
Yeah.
Yeah.
Whereas static would be one instance for every dangle.
Whereas every call to dangle would create a new const, I think.
Yeah. But if you declare it globally, like here, then I guess there's not that much difference, right, between these two. It'd be mostly the same, I suppose.
Maybe it's also that you can't create a mutable reference of the const.
It's also the const can't have values worked out at runtime.
But static can.
Yeah, you can't use them for runtime results. So, I don't understand the use of a constant, to be honest.
I suppose it's just a special number or something.
Yeah, like an edge case that you don't necessarily want to be in memory, but still, like, I don't know.
The other key point that this chapter is making is that if your static variable is mutable, then you're only allowed to touch it inside unsafe blocks.
I see.
Oh, okay. So a static variable can be mutable. Yeah, that's the difference, isn't it?
Can be mutable because it's dangerous.
Right. Whereas
Const cannot be mutable, right?
Yeah.
Yeah, by definition.
so ideally you just never use the static keyword, I guess.
Might be a nice case.
I don't see where
Static,
you-
Yeah,
if you
I
want
guess that'd
something
be a-
global. If you use something global, then you
Yeah.
probably want to think it through again.
With the variation. Let's see. Right. So yeah, this is the error that we're getting.
back to where we were.
Back to where we were. Yeah.
Tells us to have patience.
Yeah.
Yeah, so this error message refers to a feature we haven't covered yet, lifetimes. Be patient, my friends. We'll discuss lifetimes in detail in chapter 10, but if you disregard the parts about lifetimes, the message does contain the key to why this code is a problem. This function's return type contains a borrowed value, but there is no value for it to be borrowed from. Let's take a look at exactly what's happening at each stage of our Dangle code. So Dangle returns a reference to a string. S is a new string. Ampersand S will return a reference to the string S. Here, S goes out of scope and is dropped. Its memory goes away, danger. Because we created inside Dangle, because S is created inside Dangle, when the code of Dangle is finished, S will be deallocated. but we try to return a reference to it. That means this reference would be pointing to an invalid string. That's not good. Rust won't let us do this. The solution here is to return the string directly. So it's just moves value back, I guess. It moves the ownership back. This works without any problems. Ownership is moved out and nothing is deallocated. So that's good. So the rules of references. Let's recap what we've discussed about references. At any given time, you can have either, but not both, of one mutable reference or any number of immutable references. References must always be valid. Next, we'll look at different kinds of references, slices.